Good morning and happy Wednesday. I hope you've had a good week so far. I have not seen as many of you submitting work as I would like, so just make sure that you're still checking in every day. You're looking at the videos that I post and the assignments that I upload, and you're doing your work on time. Remember to at least check into the Google Classroom. Just leave me a comment that says, "Hey, I was here for today, still working on my assignment." That way I can count you present. So Monday and Tuesday, you guys did some notes on exponents, and let's look back. Let's see, you had multiplying exponents here and dividing exponents as well. And then you had some practice yesterday on Google Slides, so make sure that you were making a copy of that, doing your work, and resubmitting that. So there's a few more things within exponents that, well, actually, there's really just one more thing that I didn't want to waste a whole page of notes on, so I'll just kind of talk about it today whenever we talk about polynomials. But we're going to move into polynomials, how you add, subtract, and multiply those, and then we'll be finishing up Unit 1, and we'll have a quiz coming up, hopefully at the beginning of next week. So if you remember back to this page, dividing exponents, one of the things that you noticed was whenever you had a negative exponent, you flipped it to the other side so that it wasn't negative. And that's really the biggest thing with your negative exponents, is that you can flip whatever's happening and your exponent will be positive. So if I had, for example, I'm just going to write this here. You don't have to put this in your notes, but if I had 2 to the negative 2 power, well, we know based on the rules that we did over here, all I have to do is flip this and the exponent will become positive. So if I move this into the negative 2 up top, it became positive. So how do I make this base number a fraction? Well, we can put any whole number over 1, right? So if I flip this, it will become a positive exponent. So what you'll do is you'll do 1 over 2 to the second power. So I just moved this down and it becomes positive. So we briefly talked about that in the page on dividing exponents. If your exponent is negative, just flip it to the other side of that fraction and it becomes positive. So negative exponents flip. Any whole number that's to a negative power actually becomes a fraction. And if it was a fraction that was to the negative power, so if this was 1 over 2 to the negative 2, it would actually flip and become 2 to the second power. Right? If I flip that, it would be 2 to the second power over 1. And any whole number over 1 is just the same as the whole number. So that would actually just be 2 to the second. So like I said, you guys did some practice with your negative exponents and flipping them. The only other thing that I didn't want to spend a whole page of notes on was anything to the power of 0. So anything to the power of 0 is 1. And we'll write that down on this page that we're about to do. It's just a rule. I'm not going to go into why. It's easier to explain why when I'm in person with you, so I'm not going to do that on a video. But just remember, anything to the power of 0 is 1. And I'll show you some examples of that when we get here. So that was it for your exponents. We're going to move into polynomials now, and what they are and how we work with them. Again, we're kind of going over different ways that numbers are classified, different terminologies that we use in our equations. And a lot of these polynomials you've seen when we did our multi-step equations. So we're kind of tying it all together now. So the first thing we're going to do is write down our definition. I'm going to go ahead and apologize in advance if this video is longer than normal. I try to go fast, but I also try not to go too fast. So as always, feel free to pause the video whenever you need. So let's write the word polynomial across the top. And we're going to write the definition. What is the definition of a polynomial? It is an expression of more than 3 terms that contain different powers of the same variable. Okay, so again, that's an expression of more than 3 terms that contain different powers of the same variable. You can pause it here if you need to write that down. But if we broke down polynomial, poly means many, nomial means terms. Okay, so polynomial is many terms. There's some subcategories within polynomial. I'm just going to underline that for you. There's some subterms. So you have monomial, which if you could guess, mono, well, it just would be the mon, but that just means one, right? Monomial, one. So that is one term. For example, 8. 8 is just a term, right? There's nothing else with it. Well, we can put an x here if you want. 8x. That's a monomial, right? Then you have a binomial, which is 2 terms. So, for example, 8x plus 2. That's 2 terms. Then you have, a trinomial. That's 3 terms. You see the pattern we have going on here? 8x squared plus 2x minus x to the third. So as you can see, we just keep adding more terms. And I'm going to write over here to the side, terms are separated by, I spelled separated wrong, plus or minus. That's separated. If you spell that wrong, it's okay. So each one of these terms is separated by a plus sign or a minus. So that's how you know the difference. This is just 1. This is 2. And that's 3. Okay, and then anything more than that is just a polynomial, because we don't, at that point there's so many terms, you just say that there's a lot. There's many terms. So I'm going to show you some examples of some polynomials. I'm going to do blue, actually. The first example. 10x to the 7th minus 9x squared plus 15x to the 3rd plus 9. It's a polynomial. Right? That's a lot of terms there, and you can count them. 1, 2, 3, 4. We have 4 different things happening here, and they all have a variable with different powers. Same variable. We're all talking about x's here. Now, when you have a constant, technically you can put a variable with that, and you can make it to the power of 0, because again, anything to the power of 0 is 1, and I'll show you an example of that in just a second, like I talked about. So another example, let's say 9x squared minus 5. Okay, that would be a binomial, right? That's 2 terms. 1, 2. And then another example, this is the one that I want to show you, anything to the power of 0 is 1. So if we have 6, this is 1 term. You can make it a monomial by doing 6a to the power of 0. Okay, so we've got a variable in there with a power. This is 1 term. but anything to the power of 0 is 1. So whatever number a ends up being right here, it doesn't matter what number you choose to replace this variable. If you raise that to the power of 0, it will equal 1. 1 million to the power of 0 is still just 1. So what that simplifies down to is 6 times 1, no matter what number a is, which is 6. So the rule is anything to the power of 0 is 1. So you could make this a term with a letter beside it, 9x to the power of 0. You could just leave it 9 because we know anything to the power of 0 is 1. And then another example would be 10x to the 4th minus 2x squared plus 3x. Okay, so that would be a trinomial. One of the things I want you to remember with your polynomials, and you'll probably have some practice with this tomorrow where you've got to simplify. Before you label what kind of polynomial it is, whether it's a binomial, monomial, trinomial, make sure that you've simplified it, because I'm going to give you a trick example. Okay, so this one's trickier. 11x to the 4th plus 3x to the 3rd minus 2x to the 4th plus 8x. Okay, when some of y'all look at this, instantly you're like, oh, well, that's more than 3, so this is a polynomial. But you have to make sure that it's in its simplest form. All of these up here, there's no way I can combine them. They're all a different term. This is talking about x's to the 7th. This is x's to the 2nd. This is x's to the 3rd, and this is just a constant. None of them are similar. However, down here, I see two that have the exact same power, 11x to the 4th and negative 2x to the 4th. Those are literally speaking each other's language. They are the same thing. This is x's to the 4th, and this is x's to the 4th. So what you want to do is combine these. If I have 11x's to the 4th, and I have negative 2x's to the 4th, when I combine these coefficients, what is 11 minus 2? 9. So really the simplified version is 9x to the 4th plus 3x to the 3rd plus 8x, making this a trinomial, where some of you guys would have thought it's a polynomial. So when your exponents are the same, you can combine those coefficients. It's similar to multiplying exponents here, right? If the variable is the same and we were multiplying them, we multiplied the coefficients for those same x's, and all we did was add the exponents. So this 7 got multiplied to this 1, right? Because they were both talking about the same letters. Well, here we're dealing with the same letters everywhere, but if we're looking at the powers and they're the same, we can add our coefficients. So you have to look for similarities. Little tricks like that to help. All right, something I want to add at the bottom real quick is examples that are not polynomials. So, let's scoot this down maybe a little more. There. All right, that pen is dying, so we'll have to use orange. Write this down. A polynomial can only have positive integers as a power. Now remember, when we were classifying numbers, we talked about what an integer is. It is just a whole number. So -2, -4, 8, 10, 12. Those are integers. For your powers, it can only be a positive integer. So I'm going to show you an example of one that is not a polynomial. So if I have 10x to the -7 minus 9x squared plus 15x to the 3rd plus 9. Okay, this is exactly like our very first one. The only difference is right here. I have a negative exponent. So, not a polynomial. Okay, and then also 9a to the 1/2 minus 5. Not a polynomial. Why? Because this power is a fraction. That's a rational real number, but it's not an integer. It can only be whole numbers. It can't be a fraction. So, no negatives, fractions, or decimals. Only whole positive numbers. And I want you to bubble that or write a circle around that or box that or something. Okay. Once you've written that down, I want you to flip over to the next page. And if you're not done yet, you can pause this here and finish writing. But I'm going to flip over now and we're going to talk about degrees of polynomials. So we've talked about the different classifications of polynomials. You've got monomials, binomials, trinomials, and some examples. And now we're going to look at the degree of polynomials. Okay, so I'm going to write degree of polynomial. And this is determined by the largest exponent in the polynomial. So when we're talking about degrees of polynomials, you determine this by looking at your biggest exponent in your whole polynomial. So make yourself a table and write degree, name, example. For your degrees, I want you to go from 0 to 6. So 0, 1, 2, 3, 4, 5, 6. Okay, and then I'm going to show you the names of them and some examples. So if it is to the 0 degree, that's just a constant, and we saw that before. So 1. Okay, 1 to the power of 0 is still 1, right? Now we're going to do anything to the power of 1. So if the exponent is to the first power, these are called linear. And this looks like 2x plus 1. Okay, so again, we don't ever write to the power of 1 because it's redundant and it's not going to change anything, but you can put it right here. Okay, so if you see a variable with no exponent, you can put to the power of 1 and it won't change the value of that. And those are linear functions. When we talk about linear functions, which is a unit we're going to get to, you'll always see, is there just one x with no exponent, nothing crazy, just an x? It can have something in front of it, but is there just an x with no power? That's a linear function. Then when we get into quadratic, which is what you're going to write next, quadratic, I always say, how can you tell if this function is quadratic? You should always see squared. So you should see a squared in there, something raised to the power of 2. So if the degree is 2, in your example, that would be quadratic. Make this blue. Again, you won't see to the power of 1, but we're going to put it there for the sake of the notes. So if something is to the degree of 2, or it's squared, that would be quadratic. If something is to the 3rd degree, that's called cubic. And here's an example, 5x to the third plus 2x. Again, if you want to put to the first power, you can. That highest exponent is 3, so that's a cubic function. If the highest exponent is 4, that is a quartic. So x to the fourth plus 3. And again, if you wanted, you could put an x to the 0 power, because we know anything to the power of 0 is 1, which would still just make that 3 times 1, which is still just 3. Just throwing that 0 power in every now and then. Another one would be, the 5th degree would be quintic. And an example of that. Again, so you see that the highest exponent is 5, and then anything greater than that, you just say it's to the 6th degree, or to the 7th degree, or to the 8th degree. Just depends on what the exponent is. So if you have x to the 9th, that's the 9th degree. It just depends on your exponent at that point. So you've got monomials, binomials, and trinomials based on the number of terms they have, and those are separated with positives and negatives, so our plus symbol and our minus symbol. And then depending on the degree of that polynomial, you need to look at the highest exponent. And that's it for your notes today. I'm going to write down 4 examples. 2 of them I'm going to give to you. 2 I want you to fill in, and when you upload a picture of your notes should be completed with those last 2 examples completed. And that'll be your work for today. So, example, 6x to the 4th minus 4x squared plus 2x to the 4th plus 9. Okay, when I look at this, I'm realizing first, there's 2 things that have the exact same exponent, so I can combine these 2. 6x to the 4th and a positive 2x to the 4th actually becomes 8x to the 4th, and then I just bring everything else down. Minus 4x squared plus 9. So now I have 1, 2, 3 terms. So I know that it is a trinomial. But I have to figure out what kind of trinomial. And if I look at my degree, the highest degree is a 4, making it a quartic trinomial. Okay? So as long as you've simplified it, all you have to do is count your terms and find the highest exponent. One more example I'll give you, and then the last 2 are yours. 9 minus 2y squared plus 6y to the 4th minus y equals. Okay, nothing has the same exponent power, and there's nothing I can combine, so I can start counting. 1, 2, 3, 4. So that's a polynomial. And then my highest exponent is 4, which again is quartic. Does that make sense? If you want, again, you can put, anytime you have a variable and there's no exponent, you can always put to the power of 1, because that just tells you to do this one time. It doesn't change the value of it. If you wanted to add a variable to a constant, you'd have to do to the power of 0 so that it stays a constant, right? Because if I added an x to, or we're talking about y's, if I added a y to this, it changes the value of this. This is no longer just a 9. It becomes a 9y. And a 9y and a y are both talking about just y's. So 9y minus y is actually 8y. So I can't just add a y, because that would have an invisible power of 1, right? So if I wanted to add a variable to this, to keep it to be 9, I'd have to add y to the 0 power, because anything to the power of 0 is 1. So that would be 9 times 1, which keeps it 9. So just keep those things in mind. You don't ever have to change the equation that I gave you and add those in. It's just if it helps you kind of understand things. Anytime you see a variable with no exponent, you know that it has an invisible 1. There's always those invisible 1s. There's also an invisible 1 right in front of it. We talked about that when we were multiplying our exponents. Okay? So the next two examples I'm going to give you, they're not crazy hard. You can do them. Would be 8x squared minus 9x plus 3. So I want you to count the terms and find the highest exponent value and tell me what kind of polynomial this is. And then same for the last one. 10y to the 6th plus 8y to the 3rd plus 8y minus y. That one might be a little tricky for you. Here's your hint. You're going to have to simplify it. This one's going to need to be simplified. So when you upload your notes, you're going to do both pages of notes completely done, and these two need to be filled out. That way I know that you've done your assignment for today and taken your notes. And that's it. That's all you have to do. Tomorrow, obviously, we're going to have some practice with these. And then that's it. We've gone over everything for Unit 1 review, and you guys did awesome. So thank you guys for watching and tuning in. Make sure that your notebook is up to date. If they're notes, I tell you that they're notes. A lot of you guys are putting stuff in your notes that's not for notes. So I either upload a picture of the notes and it's titled notes, or I do the notes with you. So these are the next 2 pages in your notes that come after exponents. All right, good job, and I will talk to you guys later.